The reason why clusters are especially relevant or can be relevant to this week's assignment is because this week's assignment deals with animation. And I want to talk about textures or kind of line work or what lines are in relation to this idea of animation. Animation that's specifically non-three-dimensional or not a fly-through animation. So for a moment, I'm going to disable this and start anew. So right now I have a line, and let's say in my ADI drawing I want to create, using line work, a line that is not so clearly defined, or I want to kind of create a fuzz around it. Now one way of doing this could be that I kind of sketch this kind of feathery kind of effect onto it. And in Grasshopper, the best way to do these things is to kind of think it through. What does that mean? Okay, so first I divide it into a series of points. Great. And then around each point, oops, let me do that with points so you can see. Around each point, I want to create a line that kind of sticks out maybe 45 degrees from the line itself. And do that kind of repeatedly. And perhaps maybe even for this, maybe I want another line, or maybe I want to divide the second line in half also. Who knows? So something like this operation. So if we think about our operations, we want to divide the line, we want to get this line at a tangent, or 45 degrees from tangent to the curve, and maybe we want to subdivide it and do it again. So let's try that out. First of all, we have this line, and we want to divide it into a number of points. Let's say 15. Great. Just a little bit. And in fact, since we want our fuzz to be relative to the size of the line, why don't we instead use the divide length? That will divide our curve based on the length of each segment. So let's say 1.5 units, inches, or whatever we're using. Zoom this down. Great. And our next step is what this gives us. The divide length option is a point, a series of points, a series of tangent vectors, which are pretty key. So if we use line SDL, that gives us a start point, tangent, and length. It gets a point, it gets the kind of the vector, the direction the line is going in, and you give it a length, and then it gives you a line. So the start point is each point, tangent is this guy. And already you can see some kind of effect. Let's change the length of this to 10 just so that we can have it easy to see. Excellent. Wow. Okay, let's reduce that a little bit. So we kind of have this going on, but it's a little, we want some more control. We want to rotate this line. So let's say we want to rotate this line around these points. We want to, now if we have this line, kind of want to rotate it that way, right? Upwards, and around this point. So rotate. Now for this one, I'm going to use rotate an object in a plane because we're all working from the top view. So I'm going to take the geometry. This wants an angle, so let's say a 90-degree angle. But remember, this wants it in radians, so I convert it from radians. Let's see, this converts it from degrees to radians. And the rotation plane, the XY plane, but specifically we want the origin to be around each point. So that's a little very difficult. I'm going to hide that and type that into this. And see, now I got all these lines that are 90 degrees rotating. Now if I change that, these guys going to fall. But it's only on one side. What I can do is I can mirror it around a curve. So I say, take this geometry, this one's initial curve. This is the initial curve, right? So I'm going to take this guy, plug it in here, and wow, already I have this kind of double-edged fuzzy line, and I can change the angle of the fuzz. This kind of furry line. And you can see that what the furry line does is it expresses the curvature of the line through these kind of fuzzes, more so that the kind of straighter line gets, you don't see it, but the moment it turns, it shows you these kind of things. So this is what this specific kind of script is doing. It's kind of accenting changes in corners, inflection points. It wasn't a deliberate idea, but it's doing that nonetheless. And then if I increase the frequency of that, it becomes more feather-like, right? You can see the kind of effect I'm having. Quite gorgeous, actually, in my opinion. And so this is pretty kind of complex, or not complex, but just, it's, if we keep on using this, so become complex. So what we can do is, remember, we can use the encapsulation function. So I'll set this as an output, and actually what we want is not just this guy, we want this part and its mirrored equivalent. So we want to add both into here. So that's what we want. And as our input, we want this geometry. As a general rule, when you're clustering, you don't want to have this kind of split. So I'm going to add this thing in here. And so this will plug into that, and that will then ferry our geometry into these nodes. And I'm going to grab everything together. Add that there too. And I'm going to cluster it. So here we've created another cluster.